In this video, we will look at some review of the periodic table. Let's start with the group names. Group 1 are called the alkali metals. Group 2 are called the alkaline earth metals. Group 1 and 2 are very reactive. Groups 3 through 12 are called the transition metals, and you need to know that transition metals produce colored solutions and that they have multiple oxidation states. That's why when we name them, we're going to use a Roman numeral to indicate what the charge of the metal is. Group 17 are called halogens, and Group 18 are called noble gases. Group 18 is non-reactive because they have a stable atom-electron configuration. The periodic table is arranged so that we have metals appearing on the left-hand side. Then you have on your staircase metalloids, or semi-metals. And on the right-hand side, you have your nonmetals. You're responsible for knowing every metalloid, so we say B, Si, As, Te, Ge, and Sb. We also need to know the properties of metals and nonmetals. Metals lose electrons, they form positive ions. Their ions are smaller than their atoms, or an ionic radius smaller than atomic radius. They have luster, they're malleable, which means we can hammer them into shape. They're ductile, which means I can pull them into wire. Luster again means that they're shiny. They have low ionization energy, and they have low electronegativity. On the other hand, nonmetals are going to be somewhat opposite in that they have high ionization energy, high electronegativity. They're dull, meaning not shiny. They're brittle, meaning they break easily. They like to gain electrons, so they form negative ions. And their ions, since they're gaining electrons, are going to be bigger than the atom. So bigger than atomic radius. Metalloids, being in the middle of the metals and nonmetals on the reference table, the periodic table, are going to have properties of both metals and nonmetals. It's also important to know the phases of the elements. So remember that we talked about there are only two liquids on the periodic table. We have mercury and bromine. So the liquid metal is mercury, non-metal liquid is bromine. We have monatomic gases, that's all of group 18. And then to remember the diatomic gases, we use that acronym. HCl is fun, so HCl, FO, and N are diatomic gases. All the rest are going to be solids. Here we mentioned diatomic and monatomic. Remember that to remember the diatomic elements, those that must have two atoms attached, we note with a little subscript 2, we use the acronym Brinkelhoff. So when we're talking about, in general, any diatomic element, we're going to use Brinkelhoff. When we're talking about of the diatomic, the ones that are gases, we have HCl as fun. Let's discuss a little bit about the organization of the periodic table. The periodic table is arranged into the vertical columns, which we call groups. All the elements in the same group, well, for the representative groups that we'll discuss, will have the same number of valence electrons. And for that reason, they're going to behave similar chemically. So the Regents likes to ask about that. Which ones have similar or behave similar chemically or have similar chemical properties? Those are just going to be the ones in the same group because they have the same number of valence electrons. The horizontal rows we call periods. The elements of the same period have the same number of occupied energy levels, or shells, as they're sometimes called. So all the elements in period 4 have 4 shells, or 4 numbers in this electron configuration. So for example, if I had 2, 8, 2, I have 4 numbers. This element is in the 4th period. If I had an electron configuration such as 281, there are 3 shells occupied, so this would be an element in period 3. Furthermore, we know that the periodic table was developed, the modern day one, by Dmitry Mendeleev, and that although they originally thought that the periodic table is arranged by atomic mass, today we know that it's arranged by atomic number, which tells us, of course, the number of protons.